Hey guys, in this video we're looking at the free response question number 3 from the 2010 exam. So we have a humane society that wanted to estimate with 95% confidence the proportion of households in its county that owned at least one dog. So the first thing we were asked to do was to interpret a 95% confidence level in context. Remember, everything we want to do is in context, especially when they make a point to say in context. We already should be doing context, but if they're mentioning it, let's not forget that. Then we're given some more information. We know what our pieces here are, and then we want to use that to interpret that confidence interval a little bit further for part B. And then for C, we want to calculate the sample size that humane society would have had to use. And then if we go over here to the intent of the question from College Board, we'll see those three things. So our big goals: 1, to interpret the meaning of a confidence level; 2, to use the confidence interval to test the plausibility of a claim about the value of the population parameter; and then finally to perform a sample size calculation based off our interval. So here I'm just going to show you what College Board's answer key looks like. So for part A, they're talking about the fact that they have a 95% confidence level means that if one were to repeatedly take random samples of the same size from the population and construct a 95% confidence interval with each sample, then in the long run, 95% of those intervals would succeed in capturing the actual value of the population proportion of households in the county that own at least one dog. So notice they're talking about repeatedly doing this action, like keep doing this test. When they look at however many samples they have altogether, 95% of them will capture the true value in there. And then they also talk about the context. The county will have people owning at least one dog. For part B, our answer is no. So, because remember, look back to the language here in 1. They're going to say, does the Humane Society's interval estimate provide evidence that the proportion of dog owners in its county is different from the claimed national proportion? So the national claim proportion here is 39%. Our confidence interval, we'll see here, we have our sample proportion, and we have our margin of error here. So here's our interval. With this interval, 0.39 falls within it. So that means it's plausible that 39% could be the true value, but the question specifically asked if we had evidence to say it was different. So that's why we had to say no. So be careful. So some of you I saw when I was looking through responses said yes, but I think that was just because you're out of habit being like, oh yes, it's in between. So we have to make sure we're reading the question carefully. Okay, so the confidence interval does not provide evidence that the proportion of dog owners in this county is different from the claimed national proportion. Again, more context the better. This one I think you can kind of slide away with not having the context, but I would just keep context in it the whole way through. And finally, for part C, we're given the sample proportion, right? That's my p hat from up top. The margin of error is that 0.119. Determining the sample size requires solving the equation. So the margin of error is equal to the critical z times the standard error here. So with that being said, they go about solving, and we get 66 households for the sample. So the key ideas we got out of this question involved interpreting the confidence interval. So remember, we have a phrase that we like to use. We would say 95% of random samples of this size, and we say this size because we weren't given the size of our sample, right? So we could say, or same size, something like that, will produce confidence intervals that capture the true proportion of blank, which is the context. So we would say of households that have at least one dog. Okay, so that's our phrase that we would say when we're just describing a confidence level. Okay, don't confuse that with saying we are 95% confident that the true proportion of households with a dog, with at least one dog, lies within. That's interpreting the confidence interval, which we were not asked about. Because remember, we didn't even know what the confidence interval was for part A. It was specifically given to you after you answered part A. So don't go describing an interval. This is a difference between the level and the interval there. Okay. For part 2, we're testing a hypothesis using the interval. So basically, you're determining if the value they give, like in this case, the 39%, is within or outside of it, and what we would do with that. If it's inside, we would fail to reject. Okay. And then if it's outside, we would reject. So it also depends on the context of the problem. Like this problem was a little bit different than some of the questions we're used to. Finally, solving for sample size. So remember, Mo, your margin of error, is your critical Z times the standard error. And in this case, since it was 95%, my critical Z is 1.96. Some of you might have that memorized already, or you could go into inverse norm on your calculator, but remember you would be putting in only one of the tails, so it would be 0.025 that you would be putting in and letting that get your critical Z. And then we would take p hat, q hat, all over n, all under the square root, because we're doing the sample proportion here. So we have p hat in this case. We were given that 0.417. We have the margin of error in this case. So we're really just plugging in. You would use 0.5 if we didn't have a sample proportion, but we do in this case. So using 0.5 here would go from an essential to a partial. So here, when I'm looking at this, we have A, B, C are all broken down into EPI, similar to what we're used to now. So to get an E essentially correct, you have to mention 3 big things out of part A. You're talking about something happened repeatedly. So that's why we talk about saying like 95% of samples of this size. Like we keep talking about doing it again and again and again. They also mention the long run or using this method, but just something that indicates that you're repeating the process. And then we mentioned that we'll capture the intervals 95% of the time because we want to make sure we're talking about that 95% because that's what's given, and that's how often they're capturing the true proportion. And then finally, context. So remember, most of these things are going to rely on you to have the context in there, but having all 3 gets you an E. Having 2 out of the 3 will lead to a P, and there's some different variations that you could look through here too. And then unfortunately, having only 1 of them would only get you an I. And you'll see, you can read a little bit further in our slides here for that. Okay, and B continued a little bit more. So now with B, essentially correct, states that 0.39 is in the computed interval. The interval does not provide evidence that the proportion of dog owners in this county is different from the claimed national proportion. So that's like making sure you're saying no, because you read the question and you're saying that does not provide evidence that it's different, right? 0.39 falls within, it's totally plausible. For the partial here, you could say that 0.39 is within the interval, but if you don't draw a conclusion, we have a problem. You have to talk about like the yes or the no, preferably adding context to it. You could also have made an arithmetic error in computing the endpoints of the interval, but if your answer is right based off your interval, then it's okay. So you'd get a partial. And then for incorrect, student does not recognize how to check whether the claim is consistent with the confidence interval. And finally, C essentially is you show the right equation and have the right answer. Now, for a partial, you could have used the 0.5 or the 0.39 instead of our actual sample proportion. You might have done something incorrectly with your calculation. You could report the answer as a non-integer value. So remember, at the end, we do have to round that up because we're talking about a sample size that we're not going to have like 65.3 households. right? Like, so even though it's a little bit higher, that automatically tells me that we got to round that answer up. Okay. Notice there's acceptable, like you could use a critical Z of 2. They're not going to be too nitpicky with that rounding. You can round up to get an integer answer. And then our rubric's broken down like this. So we have all 3 essential, we get 4. 2 parts essential, 1 part partial is 3. You have some different variations for getting a 2 and 2 different variations for getting a 1. So let's go look at some student work now. So here, 95% confidence means that if all possible confidence intervals of a given size were constructed from their population, 95% of them would capture the population proportion of households in the county that own at least 1 dog. Perfect. They talk about repetitive process. 95's like capturing the true population and the context. That's great. For part B, we know we have our interval we can calculate. We have the lower bound and the upper bound. The interval does not provide evidence that the county is different because 0.39 is contained in the interval, indicating that a possible value of the true proportion or population proportion. Perfect. You're answering the question and you're saying how you know because that number falls within there. So we have 2 E's. And we finally, the student wrapped it up with a perfect one here for 4. But when we look at that, so we have the margin of error was 0.119. Our sample proportion is 0.417. And they plugged right into the formula. You don't have to show all this work out. Really, you can, don't get me wrong. But right here is good. I would definitely include these pieces as well. But in this case, remember, we have the calculator that will do it for you. So when you hit your menu and go to algebra and solve algebraically, or numerically solve, you can plug that all in and it will do it for you as well. And that's something you want to think about because especially with the time frame that we're given, we want to make sure we're saving time where we can just because we want to make sure we're giving ourselves enough time to answer all the questions and get the problem done. Okay, and like we said, we round up because 65.9, we really want there to be households that we're looking at because it's not really people. It's the whole house of how many dogs is in it because you could have a family, you could have a person living by themselves, but it'd be better to say household. But having that response here, we have all 3 parts essentially correct, so that's a 4. Looking at another student example here, if the test were repeated many times with a lot of A's, 95% of the resulting intervals would capture the true proportion of households in the county that own at least 1 dog. Okay, they're talking about repeated. 95 would capture the true proportion. Context. All 3 things covered. It's an E. It's a spelling error of many, but I see what they're doing there. For B, no, because 0.39 is captured in the interval that the Humane Society achieved. Perfect. Okay. I would really want you to show the interval just because let's show our work and be safe there just in case. But it's okay if you don't, clearly, but it'd be a little bit better to have that. So we have 2 E's so far, but then let's see what they did in C. So they give the margin of error formula, they plug in, but notice they plugged in 0.5. So we were given a sample proportion, which we should have used here, or they should have used rather. So being of 0.5, they're slightly off, and they got docked from an E to a P. So they had 2 parts essentially correct and 1 part partially correct, so that ended up being a 3. Student, they say the real proportion of households in the county that own at least 1 dog, and the confidence is 95% of the time. They have context. They mention 95, but they don't talk about the repeated process. This one's no. They're good with B though. So they show all that. They explain that why. And C, they use 0.39 instead of our actual sample hat, and then they got a P. So this student would have gotten a 2.